right, so we left off talking all about quadratics, finding the vertex, the axis of symmetry, intercepts, all of that. We talked about how if they're in vertex form, the easy way to do all of that is by transformations, but sometimes they're not. So, for instance, this problem. Hello. Okay. Bye. So with this, when we need the vertex, what do we have to find? What was our shortcut to find the vertex? All right. So opposite of b over 2a gives us the x value of the vertex. Can you tell me by looking at this, is it going to open up or down? So does that mean it has a maximum or a minimum?
Maximum.
Maximum, good. Okay, so opposite of b over 2a, so negative 6 over 2 times negative 3. So that's 1. I am really going to harp a lot on proper notation. So the vertex is an ordered pair. All you found is the x. How do I get the y?
Plug it in.
Plug it in. So if we put in a 1, so we get negative 3 plus 6 plus 1, which is 4. So our vertex is 1, 4. I put several of these on there. Why don't you guys do C? You probably don't need all of them. So do C for me. Did it open up or down? So opposite of b over 2a. So opposite of negative 4 is 4 over 2 times negative 8. And we get negative 1/4. Then you have to plug that in. So we get negative 9.5 or negative 19 over 2. I didn't ask these questions, but maybe after the weekend it's good to review. What is the axis of symmetry? So it'd be x equals, and on axis of symmetry, I am going to be very picky. You have to write an equation because it's a vertical line, so you can't, if you just say negative 1/4, you're wrong. It's the full line, so x equals negative 1/4. If I asked you, what's the y-intercept? Negative 10. How'd you get it?
Plug in 0.
Plug in 0 for x. If I asked you to graph this, do you guys remember from Friday? You start at your vertex. So negative 1/4, negative 19 over 2. Then you've got your vertical line. I drew that dashed. Your y-intercept was negative 10. I told you I wanted a minimum of 3 points, so you could go reflect that over and get your graph. Probably not a real pretty one to graph, but good to review after the weekend. Any issues with this? Okay. Since we're talking about quadratics, I pulled in something that we've kind of mentioned before. Remember talking about the discriminant when we were solving equations, so I just figure anytime I can review something that we talked about before, we might as well take the opportunity. That was when we were solving quadratics. In terms of a graph, that solution is your x-intercept, so it's basically telling you how many times it will hit the x-axis. So if your b squared minus 4ac is greater than 0, so if you did the quadratic formula and you get a positive number under your radical, what did that tell us about our solutions? remember we'd say things like 1 real, 2 imaginary, 2 real. What happened if it was greater than 0? Think about the quadratic formula. If you put a positive number under a square root, do you get real or imaginaries? Real. So we would have something plus that and something minus that. So we get 2 real solutions. In terms of x-intercepts, that means we have 2 x-intercepts. This graph would hit the x-axis twice if your discriminant is positive, because we get 2 real solutions. If it equals 0, then you end up with plus 0 and minus 0, and what's true about that? Yeah. Plus 0 and minus 0 is the same thing, so in that case, you only have 1 x-intercept. And if b squared minus 4ac is negative, then that means we get what under the radical? We have a negative, so we have an imaginary. Can we graph imaginary numbers? No. So in terms of the graph, that means you have 0 x-intercepts. So your vertex, or your A term, can tell you if it opens up or down. B squared minus 4ac could tell you how many times your graph is going to hit the x-axis. All right. Last thing, I'm going to skip that. All right, last thing I want to do is just talk about a couple quadratic models that we are going to look at. We know the vertex tells us if it's a maximum or minimum. Some common applications of quadratics are height of an object. You know, if you think about it, if you take a ball and you throw it up in the air, what's going to happen to it? It's going to go up and it's going to come back down. So it's kind of following the path of a quadratic. So height of an object is a lot of times looked at as a quadratic function. Negative 16, that's just due to acceleration due to gravity. You don't really have to know that. You're not memorizing the equation. I would give it to you. But in this scenario, S of t is telling what your height is at a given point in time. V sub 0 represents your initial or your beginning velocity. H sub 0 is your initial or beginning height. So I think you've got a box in the middle of the page. You can fill in some gaps here, talking about the quadratic models of vertical motion equation. So let's try to apply that. So a ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. Give a function that describes the height of the ball in terms of time t. So vertical motion, S of t, equals negative 16t squared plus v sub 0. What is v sub 0? Initial velocity, or velocity at time 0, which in this case was 112t plus h sub 0, which is your initial height, which was 75. If you start on the ground, what would your initial height be? 0. Okay. So then, that's our equations. So part B, I want to know when it reaches its maximum height. Well, what do you know about this? When would you have a maximum height? It's a quadratic. Does it open up or down? Opens down. Where does your maximum happen? At the vertex. So the when, that's my t. We're just looking for the t value of our vertex, which is like the x value. So opposite of b over 2a, so negative 112 over 2 times negative 16. We get 3.5. It's time. We were in seconds. If I asked you what the actual maximum height is, am I asking for the x or the y there? The y, or in this case, s is what I use, but we just have to plug this back in. So we get an actual height of 271 feet. So your actual maximum or minimum, that's the y value. Where it happens is your x. The last question, I wanted to kind of show you how to do something a little bit different on your calculator. I want to know when the height of the ball is greater than 200. So we've solved some quadratic inequalities. We could do this by hand, but I wanted to teach you how to do it on your calculator. So everybody grab one if you don't have it already. And for your equation, we're going to put in this, just use x for the variable. And I want to know when it's above 200 feet. So what I'm going to do is go to the y sub 2, and I'm going to enter a 200 there. Now, if you just graph this on your regular window, the negative 10 to 10 that it defaults to, we're not really going to see much. There's what I see of my quadratic, and I can't see the 200 at all because this only goes up to 10. So if we go to window, we can adjust some things. I know that my maximum is 271. So I'm going to make sure my y includes that. So under y max, I'm going to go up to, I'll just go to 300. Right underneath that, it has y SCL. That's your scale. It's what it's counting by. You can leave it at 1, but it's going to kind of bog your calculator down if it has to go from 1 all the way to 300. So I'm going to switch that to 10, just so my calculator can count faster as I go along. And you can change other things if we want. Let's just see if this is enough to show us. So there's my quadratic. I can see the whole thing now. And there's my line. So I set my y max at 200 and my y scale at 10. And I got this graph. Is anybody calculator showing something different? Oh, okay. And then the second one, because we're trying to find when it's above 200. So I graph 200. Okay, so y max. And then when I entered it, I used 200 as the second equation. Because I'm here to check when the height is above that. You're welcome. Okay. So I want to find when the height is above 200. So what I need to know is when does it actually equal 200? Because it's above everywhere in between here and here. Would you guys agree with that? So I need to find these 2 points. If we want to find them exactly, just using the trace feature isn't great because it jumps around a lot, but our calculator can do more for us. If you hit second and then the trace button, it takes us into a calculate menu. These are all the things your calculator can find for you. If I want to find where 2 things meet, that is intersect, number 5. Okay, and then if you watch, it prompts you at the bottom. It says first curve. It will go there automatically, so all you have to do is hit enter. And then if you notice, my cursor jumped up to my line, and it says second curve. And it does it automatically, so I just have to hit enter. And then it asks you for a guess, because this really goes on forever. So we have to tell our calculator where to look. So you just get reasonably close to your point and hit enter. And then it tells us the intersection. X is 1.393. Now that's just the first point. I need the second one. So let's repeat that. I know it's a lot of steps, so I want to make sure everybody's there. So first you go to second, and then trace. Which one do we want? Number 5, intersect. First curve, it will take care of. Just hit enter. Second curve, it changes automatically. Just hit enter. But for my guess, this time I want the second point. So I just have to move over to that second point and hit enter. So it tells me that intersection is 5.607 seconds if you round accordingly. So everywhere between. This next question says, when will the ball hit the ground? Shouldn't have moved that. So if it hits the ground, what does that mean about your height?
It's 0.
It's 0. So there are different ways we could do this. We could do it by hand. We just set our height equal to 0. And then we could try factoring, Fox method. If that fails, we could do quadratic formula. So we have any of those tools. We've solved lots of quadratics. What else could we do if we didn't want to solve this by hand?
Symmetry 0.
So there are a couple ways to do it on the calculator. The first one is to find a 0. It's a little bit different than the process I just showed you because it's going to ask you for a left bound and a right bound. If you don't like doing that, you could do it exactly the same as we just did. All you have to do is set your second equation equal to a 0. So if you don't want to learn another process on the calculator, just do it the same way. My second height is 0. So I'm looking where those meet. Now what's true about this first point over here? What kind of x is that one? A negative. Can your time be negative? No, so it hits the ground here. So we can go to second, trace, intersect. First curve enter, second curve enter. And then use your guess. And it tells me after 7.616 seconds. Just trying to show you a few of the resources you have available. I don't, yes.
What am I gonna do?
How to do
That's like yeah, I got that.
it. You're on guess to hit enter one more time. And then it'll tell you the intersection.
Okay. That was really fun.
All right, do you guys want me to do another one along these lines, or do you think?
Yes.
Okay. So you can flip your notes over and add this to the back. Alright, so this time we have a toy rocket launched straight up from the top of a building 50 feet tall, initial velocity 200 feet per second. So my height, S of t equals negative 16t squared plus, what is my initial velocity? 200t plus, what is my initial height? 50. So part B wants to know when it reaches its maximum height and what the maximum height is. So to find the when, what do? So my when is 6.25 seconds. The actual height, we have to plug that in. So I get a maximum height of 675 feet. C, this one's the calculator one. I want to know when the rocket will be more than 300. So you guys walk me through it. What do? So my beginning equation and what should my y2 be? 300. For our window, we might need to adjust it. You remember we have it set where the highest thing we see is 300, so since that's the point I'm looking for. You can go all the way up to like 700 if you want to make sure you see the entire thing. At the very least, you need to be more than 300 so you can see where they meet. So that's kind of up to you what you want to go to. I'll try the 700, see what it does to my calculator. So there's my quadratic. Since I went up to 700, I can see that part of it. Am I seeing both intersection points here? No. So I'm going to go back to my window and adjust my x's. I'm showing all these negatives. I don't really need those. So if you want, you could start it at 0 and go to 20. It's just kind of a guess and check. You try something, you look at the graph and see if it shows you what you want. Yeah, I changed my x min to 0 and my x max to 20. And then I can see both of those. So then how do we find the actual points? Second, trace, intersect, number 5. First curve, it does. Just hit enter. Second curve, it does. Yes, ma'am.
I still can't see my graph.
Okay. Go to window. Let's try x min 0, x max 20, y min, I think I have 0 or negative 10 either way. Y max, try 700, and y scale, try 10.
Oh, what was the y min?
You could do 0 if you wanted.
Okay.
Does that work? So I get 1.409. And finding the second one, so you just repeat. Second, trace, intersect. First curve enter, second curve enter. Guess, get all the way close to it, and hit enter a third time. We get 11.091.